Welcome. This DDI CADcast is going to go over hardware and system performance. I'm Michael Nolte. Here are the topics that we're going to be looking at today. So we'll be going through the hardware, the software, operating systems. We'll even look at some of the RX stuff, and then we'll get into the rest of the stuff from there. When you start talking about hardware and system performance, you start looking at, okay, what does each program need, what machine to go with, what video card to use, even what operating system to start taking a look at. So we're going to break that down and start kind of looking at the individual areas and really kind of dig into the stuff that SolidWorks, Composer, and even Enterprise are looking for in the hardware side of things. So what better place to start is let's look at the hardware, but specifically the hardware for SolidWorks. When you look at just SolidWorks itself, you have to break it down into the areas that you're actually focused on. Are we just talking SolidWorks, which is a very linear process, or if you get into simulation or flow simulation, which actually get in and branch out to the multiple areas there. Or maybe you're even using PhotoView 360 to actually do some rendering. And it'll actually use whatever core it can because it's a progressive renderer. Well, let's go and start breaking this down. Let's go and take a look at just the SolidWorks side of things. One of the first things that SolidWorks is looking for is a OpenGL video card, mainly because SolidWorks is looking for a business professional graphics card, and that's OpenGL, where it only accelerates a single window at a single time, opposed to a gaming card where you're accelerating multiple windows at the same time. Let's take a look at SolidWorks.com and see where we can actually check the video card. So I'm going to go through the support drop-down. I'm going to go over to system requirements, and this is where most of the stuff that we'll be talking about is going to be located under support and system requirements. I'm going to go in there, and there's a link just for the graphics card driver. So this is actually specifically for SolidWorks, and then we can go through and we can actually drill down and actually look at any of the system vendors of pre-built machines, or if we do any system vendor for a custom build, and then we'll go and pick out one of our video cards. So we'll pick one of them out. I do find that SolidWorks does more testing on the NVIDIA cards than they do the ATIs. Intel is just some of the newer integrated ones that they're just now testing, but I do see more NVIDIA cards that are tested. Here's the full gamut of cards that are listed, so I'm going to pick one out of the list here. And then I'll go and start checking for what version of SolidWorks I'm going to be using. Since 2013 is getting ready to come out, you will see some of these showing up in the list. So I'll go and pick out the 2013 just so I get something at the latest and greatest. And I'll go and leave it as a selected operating system, but I do have all the available ones listed there for 2013. So looking at the list, looks like we've got a Quattro 4000 that they've already tested on the 2013 version of SolidWorks. At this time of the recording, it's currently not out. So one of the things with SolidWorks is you do want to make sure that your video card is on this list. Two reasons. One, so that you get all the graphics and interface stuff that you're looking for. You get real view, you get shadows, you get ambient occlusions, all that stuff's available. On the tech side of things, if you don't have a supported video card, we can only go so far with troubleshooting the issue, because it may come down to the fact that it's a unsupported card running an unsupported driver, which also does bring up the fact that we do have the drivers available. If they're on the list, you can click on the link and actually download the driver that they've tested, that they recommend directly from the website. Some cards you may see multiples for the same card, so you may want to try with the latest one, and then if need be, go and switch to one of the other ones. Going back to our slide here, talking about CPU. One of the things about CPU is SolidWorks is a linear process, always has been, so it uses one core. I wouldn't recommend just having one core on a machine. In fact, I would recommend a dual core at the minimum, maybe a quad core, or even one of the 6 cores that are coming out. So you can actually go through and be able to have SolidWorks running along with whatever else is running, the operating system, anything else that may be running in the background. So it's always a good idea to have more cores, even though SolidWorks will be just using one. That is slowly changing in different areas. There are some things that I've seen where when you open a document, it'll actually use multiple cores. So more cores, the better. Here's the thing with CPU or processors, though, is if budget is a constraint, though, you want to spend more money towards processor speed, not multiple cores. So I could probably have better performance in Core SolidWorks if I was actually running a 3.4 gigahertz dual core processor, opposed to running maybe a 1.8 quad core processor. So I do want to spend a little bit more money or spend the extra cash for getting a faster processor rather than multiple cores if SolidWorks itself is my main focus. Large assemblies, that type of thing, organic surfaces, those really would make use of the faster speed there. When we're talking about RAM, SolidWorks' minimum requirements that they're saying is 2 gigs of RAM. I definitely would recommend, if you're running a 32-bit operating system, max out the RAM. Try and get up to 4 gigs on a 32-bit operating system. If you go with a 64-bit operating system, then what you can do is go higher than 4 gigs. That's the cutoff for a 32-bit operating system. So on a 64-bit, it's pretty common to see 8 gigs, 12 gigs, 16. If you get into the simulation or flow, you may even get into 24 or 32 gigs worth of RAM. Looking outside just Core SolidWorks itself, we start getting into things like simulation and flow simulation. Big thing with simulation, it uses 1 or 2 cores, and that's it. And that is not just statics. There are other studies that only use the 2 cores. It's not really until you get into a flow simulation, which is a separate program than regular simulation, that will actually use multiple cores. If you own multiple licenses of flow, you can actually load flow simulation onto other machines and then actually hand out some of the workload over to the other machines. Keep in mind, you still want to keep your models simple, because when you go to mesh it, still using single core. So when you're actually running the study, then the solver does make use of the extra cores. With simulation, flow simulation, both of those you want to spend a lot more of the effort in getting more RAM. That way you're actually boosting up the performance on that end. For PhotoView 360, it being an add-in, they brought that in a few versions ago. It used to be a standalone program, now it's built into SolidWorks itself. It is a progressive renderer, so whether you're actually just doing a preview or you're actually doing a final render, it will use as many cores as there is in the machine. Something to be said about cores, though, some machines will actually take a processor and it'll hyper-thread it. Hyper-threading is essentially taking one core and switching it into two separate cores. So in some cases it may actually be worthwhile to turn off hyper-threading just so you have one core focused on things. PhotoView is not really that case. You might, with the simulation or flow simulation, turn off the hyper-threading, but not with PhotoView. The more processing power, the better. The other thing too is the more RAM, the better as well too. It'll help with the speed of the rendering process. So PhotoView 360, as many cores as you can. Speed for simulation and PhotoView on the cores itself. Yeah, you can probably go to mid-range if the budget restricts you getting multiple cores that are really fast. One thing I haven't mentioned up to this point is hard drive. Okay, so what do you need for a hard drive? Well, hard drive really depends on how much of your stuff you're storing on your local machine, or is it getting pushed up to the network drive. It's always a good idea to have more storage than less, because it's definitely gotten a lot cheaper than it used to be. As far as speed of hard drive goes, typically I recommend a 7200 RPM drive if you're going with a traditional spinning type of drive. But one of the things you can get into, though, is there's solid state drives, which I have seen SolidWorks run on a solid state drive quite quickly. So those are faster drives, so the software does work faster as well. There is also a new style of drive, which is called a hybrid drive. Typically they'll have like 2, 4, or 8 gigs of solid state disk in the front end of it, and then it'll actually have a regular spinning disk on the back end of it. So it's a single drive, but it actually combines the best of both worlds. A little bit cheaper than a straight solid state drive, and you can get usually a little bit larger. I haven't done any testing myself on them, but it is something to take a look at as far as if budget's a constraint rather than jumping straight to a solid state drive. Looking back at the web page here, let's go and take a look at where I'm getting all this information. So I'm going to back up to the hardware system requirements page. and we'll actually go into these Solidworks system requirements. And this actually gives you a full list of all the detailed stuff that you actually get into. These, again, are probably minimums. I always recommend, if budget allows and you're wanting your machine to last a little bit longer, always up the ante and try and get into a little bit faster, a little bit better machine if the budget allows. Okay, so let's start talking about PDM Enterprise, or Enterprise PDM. And this is more on the server side of things. On the client side of things, really doesn't need anything other than a Windows operating system. So the client side, pretty much no-brainer as far as that type of stuff. Windows XP, Windows 7, handle it no problem. On the server side of things, they recommend actually to have two different servers, one for the archive server, one for the database server. The archive server is actually where all your files are actually being stored. So on the archive server, it's just a matter of storage. You need a little bit of RAM, single processor, no big deal, but again, good idea to have multiple cores just so that it'll handle the extra load of files being pulled off of there. The archive server, the database server, that's actually running SQL. And SQL is a very efficient database, but it does actually consume a lot of RAM and a lot of CPU usage at any given moment of time when it needs to influx and actually handle the requests that are coming in from multiple users. So always a good idea to maybe shove that onto a different server, increase the RAM, maybe multiple CPUs, just so that it can handle everything that's being thrown at it. And again, this is just a recommendation. You don't need to actually do two separate servers if your company isn't large enough that you don't think you need to do that, or if budget is a concern. And again, it can always be upgraded later on and then split separately. Make sure you do go through the installation manager, though, if you do decide to move them to separate machines, because there is a detailed step as far as migrating the servers over to other areas. But again, it's all one of those things that budget can be one of the concerns there. Moving on to the next final section of the hardware area, we're looking at 3D Via Composer. 3D Via Composer is a program for creating the assets for maybe a tech illustration or an MOT traveler, or maybe an instruction sheet, or maybe any number of types of documentation that you might be doing. If you haven't seen 3D Via Composer, definitely check out 3dviacomposer.com. It'll take you out to the Dassault website. But it makes use of the existing CAD data. The other part about Composer, though, is it actually runs very thin. So we can take an 80 meg assembly and drop it down to hardly anything. On that side, though, still probably a good idea to talk about some basic hardware requirements. It does work a little bit better with an OpenGL video card. Again, not required. Keep in mind you might be running Composer on a machine that's not even running SOLIDWORKS. So this might not even be the CAD guy. Again, multiple cores is always a good idea. Processor speed, really not a concern. Mid-range or whatever. And then RAM, again, typically any more 2 gigs is a very minimum. I would almost run into 4 gigs, or if you jump to the 64-bit operating system, go and do 8 or something more, just to handle everything else that you're doing besides just the Composer side of things. Software. Okay, this is more an area of software outside of the main program that you're running. So what else might you need? Okay, antivirus optional. Always a recommendation just because of outside influence. But if you're not connected to the internet, like some of our users are, you don't need an antivirus. So don't put one on there because it'll actually slow the entire process down. Do always make sure you turn off the antivirus when you're doing the install of any of our programs, just so that it doesn't block any part of the install there. Some of the other items that we do need on the machine is Microsoft prerequisites. Things like .NET Framework, Visual C++, VSTA, which is Visual Studio. Those actually get loaded during the install, but occasionally you need to load them manually, or maybe one's acting up on you and you have to uninstall it and reinstall it. Those actually more and more are starting to get built into the operating system. For example, .NET Framework, if you're running Windows 7, it'll actually be part of the operating system. I do want to take a moment to actually take a look at our website, or if you go to the ddicad.com website, come down to training, go down to Tech Center. Tech Center is where we actually store all of our archives, all of our tech tips, all the other items that we're looking for. If you come over to the right side here, and we go and type in Microsoft as a search, first item is a tech tip that I wrote a year or so ago that actually goes through the list of the prerequisites that SOLIDWORKS and some of the other programs are actually using. This is just straight out of the SOLIDWORKS knowledge base. So if you don't have a customer portal, log into solidworks.com. Make sure you create one. But this is information just comes straight from there. I've also included some links down below. As long as the links are still good, you'll be able to download those again. Those installer files are also on your SOLIDWORKS DVD as well. So definitely make use of the DDI Tech Center for pulling some of these resources. Back at our software page, SQL. If you do PDM Enterprise on the server side, you need SQL, but when you actually purchase Enterprise, it actually comes with SQL, so you don't have to worry about that. Also, the new SOLIDWORKS Electrical, it also does use SQL, but it also comes with SQL as well. Microsoft Office, kind of an optional thing. Certain things in SOLIDWORKS itself, like Design Binder and design tables, those actually make use of Word and Excel. Don't recommend going anything older than 2003. In fact, 2003 is getting a little old at this point. Definitely look towards the newer versions. On the 3D Via Composer, you might be using Word or PowerPoint to actually do some of your presentation stuff with. So you might use that as your publishing, along with maybe Adobe Acrobat Pro or maybe Adobe Illustrator there. Moving into the world of operating systems, SOLIDWORKS and 3D Via Composer and Enterprise, we are actually a certified Microsoft product, so I don't see us going to the Mac environment anytime soon. I do know we get those calls on the tech side all the time, but we are a certified Microsoft partner there. So we are in the Windows environment world. Windows XP, one of the things that you've probably been getting warnings already is the fact that once Service Pack 5 hits of 2012, we will no longer be able to support any newer versions of SOLIDWORKS on Windows XP. Not to say that you can't just stay at 12 Service Pack 5 and stay with XP, but I would definitely recommend if you're getting into a new machine, definitely go with Windows 7, or if it's later next year, then you might want to actually get into a Windows 8 machine. Yes, Windows 8 is already on the slate for coming out later this year, 2012. So with that being said, we don't technically support Windows 8 as of yet. If they follow the same thing that they did with the Windows 7, about Service Pack 1, maybe Service Pack 2 at the latest, then we'll actually start supporting Windows 8. I do know that some of the techs here have actually been running the beta version of 2013 on a Windows 8 environment already. So not supported yet, but it will be. It's just a matter of the timing. The other thing to talk about with operating system is what version to go with, 32-bit versus 64-bit. Well, earlier when we were talking about hardware, RAM was one issue, so you can't get above the 4 gigs if you're running 32-bit. Running 64-bit, throw in as much RAM as you possibly can. It actually has a very high cap on a 64-bit operating system. The other thing too is if you're getting a brand new system, definitely recommend getting 64-bit. Almost all new programs are actually 64-bit compatible. The other thing is, especially when you get into the Windows 7 environment, it's actually a lot more efficient with managing the use of RAM and also processor speed. Or processor resources, I should say. So 64-bit, definitely the way to go. We've been running it here at Digital Dimensions in the Tech Center for quite a while, and it definitely has performance enhancements depending on what area you're working at. Alright, last PowerPoint slide to go through 4 different areas. System performance extras, I guess. We'll take a look at the Solidworks RX. I'll actually bring that open and kind of look at some of the items that are there. Talk about large assembly design review, kind of show you where that shows up. Defeature tools, also another way of simplifying. That's mostly if you're going to send them out to other users that you don't want to see the internals. But defeature can also reduce the file size, also increasing the speed. And SpeedPack, I'll talk about that one right now just to kind of get that one out of the way. The idea behind SpeedPack is so that I could take a full engine, and if I needed to send it over to a different department or a different SolidWorks team, and they didn't need all the inner workings and everything, that all they need is kind of the graphic representation of what it is and a few mounting points. I can actually pick those individual faces as being used for my mates, and then everything else would turn into essentially a graphic. Creates another configuration. Very useful way of reducing the size and making it a lot more efficient for another group or another larger project. Maybe I'm actually putting that engine into a car. So SpeedPack, take a look at it. It's in the SolidWorks help file, or we also do have stuff on our tech center that actually goes into SpeedPack. Also defeature as well too. Help file, be able to get into that. I'll show the RX and also the large assembly design review. Large assembly design review kind of affects when you're really working into the larger assemblies. You can actually turn it on with assemblies that are smaller than 5,000 parts, but you can also it'll auto turn on if it's over 5,000. So the way where you get it from is you select your assembly, and then we get this little mode drop down, and this is something new that they added with the 2012 version, so this version going forward. So large design review mode, we'll go and select that option, and then we'll go and open it here. And it will still take a little bit of time, but not if we were actually opening up the full 5,000 part assembly. So I am going to clip out a section here just so that we don't have to stand here and wait for it. We do get this little information page that shows up letting us know what it is, so I'll go and accept that, and then I'll let it proceed to actually opening up the assembly here. Alright, so we're open here. Keep in mind this was actually open across the network from one of our servers here, across the wireless network, so kind of give you an idea of what it's able to do without having to load all the assemblies. So it is a full assembly, so I can actually rotate it around so I can look at it. I can zoom into certain areas. The level of detail might be a little grainy, but it is still a lot better than not being able to open the assembly at all on certain machines. So I do still have that. Again, keep in mind this is a very large assembly, so if I go Tools menu, Assembly Expert, this will show you the total part count. Obviously some of them are duplicate because I have a bunch of rollers going up through the conveyor there, but again, very functional. If I click on a part, it'll actually show up in the tree there for me. So I can still see part names and all that type of stuff. I do also have the ability of doing walkthroughs, so I can switch over to the Display Manager tab. I can do walkthroughs. Also, this large design review also gives us the ability of doing snapshots, so we can keep orientations and that type of stuff available as well. You can still pull measurements, so there's a lot of functionality that's still there, but not having to take the overhead of a full large assembly being opened. Alright, so we'll wind down here with the SolidWorks RX. I've got some of the tabs listed there, so we'll go through the diagnostics, troubleshooting, system maintenance, problem capture, and also the benchmark tabs within the SolidWorks RX. Alright, so this is the SolidWorks RX program. We'll go and zoom in here so you can see it a little bit closer. It shows up in your Windows Start menu, All Programs, SolidWorks Directory, SolidWorks Tools subfolder, and then you'll see the SolidWorks RX program listed there. It has actually been included with SolidWorks for quite a while. Definitely make use of it. It does have lots of useful information. I'll go and switch over to the Diagnostics tab. The very first item ties back to our hardware section, goes through what the machine is. You can tell that I'm actually running a laptop. I've got a Quattro card, which is a OpenGL video card that's on the SolidWorks approved list. Gives me my video driver card number. It tells me that it's supported. and if I did need to, I can click on the link and it'll take me to the website so I can look up my video card, get the appropriate driver for the version of SOLIDWORKS that I'm running. Keep in mind, the driver version may be different between different versions of SOLIDWORKS. So you may have just upgraded to a new version of SOLIDWORKS. You need to get a new video card driver. Alright, troubleshooting tab. This is essentially a link out to the SOLIDWORKS' website. Notice it does require a login for access. If you are current on maintenance with Digital Dimensions and SOLIDWORKS, you get all your service pack updates. You also get access into some of these additional links there. The real advantage is the fact that you're able to get into the SOLIDWORKS knowledge base, and you're able to get a hold of a tech here at Digital Dimensions. Alright, so we'll switch over to the System Maintenance tab. This one, typically you don't need to visit all that much, but essentially what it is all the temporary directories that SOLIDWORKS makes use of. You can go through and purge those out. Plays a bigger role when you're running simulation, because Sim will actually use these temp directories to actually store the solver data temporarily. So sometimes they can get overfilled and it'll slow the machine down. So definitely run the system maintenance every so often. If you do have a problem that's a repeat problem and you're able to capture it, the problem capture tab allows you actually to record a video of it and be able to capture that. It also grabs some additional stuff, and then we'll create a zip file that's real easy to send or upload to us. Let's go and switch over to the last tab. This very last tab is the benchmark tab, where we can actually run a benchmark test on our machine. Recommend do a fresh reboot of the machine and then run this. That way it's a good example of SOLIDWORKS running. The other thing to keep in mind is if you don't have the premium or pro version, you won't be able to do certain areas of the test, for example photo view, with the rendering aspect of it. So this is a great area just to kind of see where your machine is comparable to other systems. As to where this information is listed of other users, we can actually go back to our SOLIDWORKS webpage. We'll go back up to the hardware and system requirements group. Again, that's support, system requirements. There's actually a whole area for hardware benchmarks. So we go into that section, and we're looking for this link called Share Your Scores there. So if we go into that option, then we actually see the scores of other users. Keep in mind, some people will actually tune their machines or overclock their machines, so you do have to take this list with a grain of salt, but it is a good indicator of kind of your results compared to others. Smaller numbers are better. Ones that have 0, it just didn't test that area. If you click on the little plus sign, you'll actually get more information on that particular system. Currently, I don't see that they list the amount of RAM on these machines, so that is something that I don't see there yet. But it does list you processor, video card, all that type of stuff on there. Great resource, especially if you're getting ready to get into another machine for running SOLIDWORKS, 3D Via, Composer, or running Enterprise there. Alright, so let's go and wrap up for the day. Thank you for viewing this Digital Dimensions video tech tip. Please visit us at www.dicad.com.